Hello, good day, I am back. If you remember, the last lecture was all about gasketing, EMI, some what do you call little provision about the skin thickness and all that. The link has been posted. So, my suggestion is most of these are industrial practices. So, whatever the industry gives as white papers or copyright with mention of their work, you should read the original and you take a stand on it, because enough money has been spent on it and some of the things are specific. Now, I will take on to, I am sorry, I will take you on to how to make much easier small enclosures using aluminum extrusions. The advantage of an extrusion is that it is closed on 4 sides. Okay? You have a nice closed on 4 sides, and then you need to provide an end cap on both sides. That is one version of it. Another, some of the other versions are 2 half extrusions are made with a lip. So, such things are also there. So, you can attach those 2 things together and put things. Advantage being, compared to die casting, it is a little cheaper and you still have control about one dimension, at least the length of it. You can make it a little longer, a little lesser. So, you can see extrusions are available at various lengths, and then the manufacturers or the packaging enclosure packaging people try to cut it to a correct length and then assemble the end pieces. So, I will tell you 2 variants of it from one of the known companies. Again, I would like to acknowledge that it is their work, and then as a student and as a practicing engineer, better you be aware of it. And again, with the caution that you blindly copy those dimensions, you will go up to some point, and then after that you will not get the other hardware that is required to keep it in place. Yes, it is expensive to buy the things, but you can always get a quote if you are doing it in hundreds of pieces. So, please look at the monitor. These are all those extruded cases. If you see here, there is something here, there is something here, and then the end pieces are all attached together. But what you need to notice is, you see this beautiful, very helpful symbol here, IP65, saying it is of the protection class, that it is sealed, absolutely sealed, such that dust and such things will not enter the place, and even if it were to fall in water, temporary immersion is possible. If you look at some common features about all this is, at least in this case, you see here very nice visible fasteners are there, which are holding both the front and end panels together. And further feature is that the corners are all reinforced. In fact, now I will put it here saying aluminum case with corner guard. You would have noticed it even within your multimeters or at home occasionally with your mobile phones, which come with a hard case. If you protect the corners, a lot of times shattering can be prevented and overall damage can be minimized. And if you are to use proper elastomers, loosely which we call rubber, saying you have butyl or nitrile rubber inserts, they take care of the shock a little. It is not as a full, if you were to give it a shock of 30J, it will be fully isolated. Such a thing is very expensive, if not almost impossible. Some isolation will be there so that corner damage is not caused. You want it bigger, this thing. I will now start with, you see, if you see this left side enclosure, it is obviously dark, and then this one is slightly better, white, and then you see the height of it is, you have these full equipment including a front panel. I do not know if this is just a mock-up or it is a real product. And you can see there is a display here, and then you can see various things. This to me looks more like a model. You know why? You will notice that here there is a small typical error made by novices. Thing being, you have some input and output, either it could be a socket or it could be a switch or something, and sadly the labeling is below. So, the moment you insert a cable or then you try to adjust and put your finger or a screwdriver or something, you will not be able to read the label. Next time, just go around, look at all the various equipments that are there in your lab. One of the first thing you will notice is generally people will take care of it. Same way, here on the right there is something here, and then something else is written here, and then there are beautiful graphics including an on-off switch, including this an up and down and so on like this. Magic is all this you can add to a available enclosure. So, subsequently down if I go, I will show you when I go down, please look at the monitor. You see here some very nice description is given of all these items. This is what I wanted to show you. Only a few of the very small items are probably fully extruded, but if you see this carefully, we have a bottom chassis like device here. You have seen this here. I loosely call it a chassis, and then at the top you have another cover, and this is where the all their expertise and engineering skill and all their development and engineering inputs have gone into it. Once we close both of those things together, first thing you will notice is it fits extremely well. Now, if you look at the you have seen here, we have a 2 panel gaskets, top and bottom covers, there is a cover gasket, and then there is an end panel. Now, going back to this dimension again, you see here number 5 are those gaskets which will ensure watertight joints. Though it is a casting, rather it is an extrusion and it is prone to a little bit of warpage, and it is not as rigid as other tough materials. Provision of this gasket into this groove and then the top portion overlapping into it. And if you snap it in place, it becomes watertight and immersible. You can happily leave it under water. And then other features which I would like to point out is, you see this number 4 item, it is a panel gasket, something in the front and something in the back. Though there is no clamping holding item number 2 and 3 together, once you push it inside and then provide this gasket number 4 on both the sides and then put item number 1, 2 numbers front and back panel, push together and apply sufficient torque, it becomes extremely watertight. You see here. Now you will notice that the small gaskets which are coming here, you see this gasket and all, they have been so carefully engineered that this integral gasket which is used for sealing just projects out of it, and then things are perfectly, they fit each other. Life can't be better than this. And then you see here even the screws which they use, they also have a proper recess here, and then probably the screw hardware comes with its own set of M2.5 into 8 pieces and necessary things, and a small hexagonal Allen key which is also included in it. Usually my suggestion is you have a look at it and then no point in copying it. You see, very important thing here is, you see the aluminum grade also is mentioned. There are 2 numbers against it. In an earlier lecture I had mentioned to you about the annealing condition. One is, it is a 6-0 series of aluminum alloy, and then T5 is the annealing grade which makes it optimum. There is a combination of both reasonably good heat conductivity, some amount of machinability so that you can carry out operations. In case you are an engineer who likes to make few one-off items, if you are to make a drawing and then pass it on to a fabricator will know how to deal with this. And then you see extreme right, color and finish. Oh, you have so many things. It comes under color, has the front and rear panels come with, you can have a black or grey, basically if you want unpainted, that is the material that is used for injection. Then there is a navy blue color which is painted. Probably not exactly intended as a ship bound or naval equipment, but it is just so many things, like you have Admiralty brass, and then you have olive grey schamic. These are all standard things which have been associated with reliable long term equipments. But compared to what was used during the war time, these days the polymer mixing and then including this aluminum extrusions and all this, the technology has improved very well. And then you see something about the gasket. So you have 2 gaskets. Panel gasket is a silicone which is dark grey or black, and then the cover gasket, that is the front and back gaskets, come in white and grey and thing. Most important you need to notice is, if you see that aluminum extrusion comes in anodized finish. I do not know if you recollect my pointing out to you. By definition, an anodic layer is non-conductive. Aluminum oxide is non-conductive. So, it has a small advantages. One of them is accidentally you are not likely to short circuit something, especially with voltage. But it is not a hard anodized thing, as such there is no guarantee that you will need to, there is no guarantee that it will be an insulator. Only thing you need to think a little about is, earthing does not take place automatically. If you have to provide earthing, you need to probably machine off some small portion of the anodic layer and make some arrangement such that an earthing lug or an earthing crown washer or such things have to be attached to this. Having spent enough time, I would like to, it is nothing, that finishes which is given there. So, all the combinations he has shown here. If I go down further, this is the one which has been given here. So, most of the dimensions which we know are all included here. This what I had orally told you at that time. This is almost like a generic. You see here a cover gasket can be installed. Oh, I forgot about this thing what I wanted to mention, which I told you earlier orally. Custom lens of the extruded panels are available. So, and in fact one of the manufacturers offers in another extender gasket on this side. So, if you have one here and one more here, okay, let us say this is the bottom and the top is matching, is a small packing which will allow you to extend it by another 10 to 20 millimeters and a corresponding panel fitting with that. It is not a firefighting or afterthought. Sometimes that panel on the side is probably also used for putting connectors or some other hardware, including maybe some guide so that it assembles there, or for stacking purposes and all that. But remember, though you can extend it like this, front panel is still you need to think about it. So, combinations of the then length is under our control, because now you have a look at it, how to install a cover gasket. It looks obvious. Insert cover gasket into the joint grooves on the bottom cover. You see here, while that is simple, this is to me it is a very, very critical observation. It is not just a matter of just read and forget, or this thing. Ensure that a small portion of the cover gasket protrudes out in order to maintain a seal with the panel gasket for 65 protection. So, we have a front panel and then the small piece has to touch there. Generally, if it all comes with in the kit form, all these have been cut to length. Why this caution has been given is, it is still a compressible gasket. This compressible gasket, while installing it, if you stretch it, it becomes longer. Similarly, if you try to push it inside, the chances are you will be squeezing it in without enough protection. So, I think it is a matter of little bit of, I will not call it trial and error, I will still call it a good exercise. Now you see here, if you see a little closer, every detail you would like to have has been included here, including how long would you like your inside elements, that is including the, in case you have a printed circuit board, how long should the printed circuit board be, or it is not just a question of a printed circuit board, you have so many other hardware. Occasionally passive devices like transformers, capacitors and sometimes relays, and the unavoidable ubiquitous connectors require exact space. So, if you see here, if you see a little closer, nicely marked out area is there saying how much of space is available for you, and then how much of it is, can be used for populating the equipment inside. You have seen here top bottom cover length, how much is the cover length, and then how much is the space, very small thing. See, for a height of 34 mm, a small d, probably it means a small height or small depth, almost 18 mm is covered up in all the hardware and the cover and so on. But then it is good, this 18 mm is maintained all through. As we go down still, you see here 59 to 41 and all that, typically this is how lot of interest has been, say 45 to 64. As you go down, even this 18 mm is maintained here. So, now you have all the necessary dimensions for you to maintain both an external footprint of your whole combined device as well as the internally how much space is available. In general, contrary to our popular perception, you have to start with an enclosure provisionally and see how well you can package all the hardware into that. Now, it will come back to the original thing. Do we make the PCB or do we start with the enclosure? So, obviously a minimum of 2 cycles or 2 iterations are needed. So, it is good to start here to find out how much, what are the spaces that are available, then go back to your electronic breadboard, which I am sure depending on your skill, whether you are already confident that it will work directly from simulation mixed mode signal analysis carried out in a package, or you have physically tried out various things. The advantage here is you have an enclosure. If you can take one which is a little bigger than what is required, each dimension should have an extra of 10 millimeters. Overall, the volume you may end up with extra 20 or 25% more, and then you can carry out almost a physical simulation of to arrange the components. Once you have the physical simulation, now you can go back and have a look at all these beautiful options that you can take care of. You see here cross section view of the extrusions are given here. Seen here. The previous table and the drawings which I have read out for you included the outside rubber feet or padding or soft things. This is the actual extrusion details inside itself. Now you see here 25 to 17, typically it looks like about 8 mm is the what you call build up from the lowest point here to the topmost point. Now if you have to carefully try to understand this drawing and stick within this possible around 49.6 is very what do you call tight. It is possible for you that see here now same thing here, even this (27 to 35), about that same 8 mm is there. Similarly here also 60 to 49.6. So in this case the only difference here is slowly you see that 10 mm, a little bit of modification of the extrusion in the extruding stage, in the extrusion stage, not the physically modifying it. So the manufacturers, I expect now, have spent a huge amount of effort in keeping all these things the way you want it. So almost squarish section at the left, and then further if you go down, you see here more and more interesting combinations. Any combinations you can think of is probably included here. This is why I tend to accept this as a beautiful alternative for us. You have seen this, how well details are given. Only one small caution is, good, I have come to the correct portion where I can probably continue with my eulogy or tirade or whatever you call it. So far my concentration was on the total internal cross section, maybe a little bit of the length. Now you see how well provisions have been made such then you can mount your hardware. And about mounting the hardware, one more thing is you cannot afford to machine the surface or go about making holes, drilling or something like only very, very unavoidable conditions, like one of them I was told you was about the earthing, and the other thing is you really have to do something. Operations need to be carried out on the aluminum extrusion, but generally as far as possible we avoid it. Now you see here a small detail, a small 1.7 has been marked here. I will take you a little closer in this. You see this small line, you see this, there is a beautiful 1.7 mm groove which runs through the length of the extrusion, and then you see the pitch also. So at a pitch of 3.5 millimeters you have 3 grooves. Obviously you can put them to good use. One of the easiest is if you have your traditional 1.6 millimeter glass epoxy or phenolic, either paper or cloth phenolic and so many other things, including metal clad PCBs, PWBs if you would like to call, they can be happily slid down the groove. Good idea. And then this is where I was trying to tell you also, in the some conditions of, if you would like to have some continuity, probably you can emery that groove, that is pass a small emery or something. This is our practical experience. And then I expect that if you ask the manufacturer, they probably give you a masked version also. Advantage of this emerying is it will give you an electrical continuity, including a little bit of grounding, but almost guaranteed continuity with the PCB. So, it looks insignificant, but the reality is you have all this. In this year, no? Maybe because of manufacturing tolerances it has become 1.8. So, anything 1.6 plus. Okay. You see here, as they become bigger in this box which is 90 or 80 mm gap, you see that we have large number of these things are available. What do we do with this now, and why do I continue to talk about it? I continue to talk about it because we have tried to use this occasionally, and then you see here that if you were to mount some load bearing plate, which is also typically around 1.4 millimeters, you can mount all your heavy hardware onto that plate. So, it is, you can call it a chassis like plate, and then if you properly put necessary grooves, stoppers, and then maybe something to prevent them from vibrating, there is a provision, very much, very good provision for us to mount other hardware other than just the printed circuit boards. That is the reason they have given all these beautiful things. And you see here one more, there is something called grooves for sliding nuts. So, I will try to take it a little closer. Why would we need to push things here? Obviously, if you want to mount something a little more rigidly and connect it directly to the chassis, which is a load bearing, what do you call load bearing member, you have thin nuts which are just about as wide as what is required. So, you can push the nut through it and then probably assemble things directly, which is that I was talking to you about, that beautiful engineering which they have carried out on our behalf. Slowly we are coming into optional hardware which they have made it. This is where I have said their engineering or detailing skill shows through extremely well.